Now, when we try to identify igneous rocks, we look at the texture and the composition of the igneous rocks. So we have many different textures that you see here. Sample number 50 has a glassy texture, and sample number 51 has all these holes in there. This is because of the escape of gases from the lava, and it's really the froth of the lava that has been preserved as the lava solidified very rapidly at the surface. So this is a very porous texture. It has a name. You will look in your charts and discover what the name of this texture is. Sample number 52 also has the same texture with all these pores and holes for the escape of gases. But the difference here is that this is light in color, so it has a different composition. However, it has the same texture as the previous sample 51. Now, sample number 53 has another texture. If you look carefully, you will see that there are two textures here. The ground mass or the background of this rock is fine-grained, meaning you cannot see any minerals with your naked eye. But scattered among or within this ground mass are these black minerals. These black minerals that you can actually see. These are called phenocrysts, and these phenocrysts are sort of floating in this fine-grained ground mass. The phenocrysts are larger in size than the crystals of the ground mass. So what this texture is a texture where you have two stages of cooling. The magma was cooling slowly underground, forming those black crystals, and then it arrived at the surface and poured out, and the rest of the magma cooled very rapidly, forming fine crystals. So the coarse crystals are surrounded by the fine crystals, giving two textures for this rock. So this particular texture where you have two grain sizes has a particular name. So you would look up your book and find out the name of this texture that indicates two stages of cooling. Then we look at sample number 54. Here you see a very fine-grained texture. Fine-grained texture meaning you cannot see any mineral grains at all. This texture also has a name that you will find in your lab manual. So this is sample number 54. Sample number 55 has larger crystals that are this is sort of medium grained, and you can see the crystals with your naked eye. So this is sample number 55, medium grained. And here you have sample number 56. Sample number 56 is again fine grained, just like sample number 54. You can't see really any crystals in there. Sample number 57 is coarse grained or medium to coarse grained, just like sample number 55. However, this is much darker, different color combination here. Here you have a lot of light colored minerals. Here you have a mixture of both. And here you see sample number 58, completely composed of dark minerals but coarse textured or coarse grained. Now when you see these coarse grained rocks like 55, 57 and 58, that indicates that the magma solidified beneath the surface of the earth, where the minerals slowly crystallized. So because the magma was cooling very slowly. So when the minerals have time to grow and crystallize, they grow into larger crystals. Now, when the lava flows out on the surface of the earth, the cooling is much more rapid. So lots of minerals crystallize at the same time, and they don't have space or time to grow large. As a result, you get a fine-grained rock like number 56 and number 54. Now, the froth of the lava at the surface, the bubbly part, is what results in sample number 52 and sample number 51. Now, one rock that I did not mention is this one. This is number 59. This one has really large crystals, more than 2.5 centimeters in size. Now, this texture that you see is a special texture, and this forms usually in the late stages of cooling, when the magma is quite fluid and the minerals grow really large, creating this texture. So all these textures have names. I've given you the name of the first one. Number 50 has a glassy texture. Now, these two porous rocks with lots of holes in them for the escape of gases have a different texture. The fine-grained rocks have another name. Coarse-grained rocks have another name, and very coarse-grained rocks have a different name. So you will look in your lab manual and find out the names of the different textures. Now let's see how we classify or group them based on their composition. So you have these two, sample number 51, sample number 54, and sample number 58. These are the darkest looking ones, and these are all mafic rocks. So you can see here, I have all three of them in my hand here. All these are dark in color, but the only difference between them is their texture. So they were all produced by the same composition magma, all produced by mafic magma. But this magma solidified beneath the ground and created large crystals, and therefore we have a coarse-grained mafic rock. This rock was formed when the mafic magma reached the surface and cooled very quickly, forming a fine-grained rock. And this is the top of that lava where all the bubbles were, that got preserved as this rock. But they all came from the same mafic magma. Now I can take all the felsic rocks in my hand. So I'll take the first one, will be the frothy one. Then I have this fine-grained felsic rock. And then I have a coarse-grained felsic rock. And then I have a very coarse-grained felsic rock. Sorry. And so here we see again the different textures produced by the same magma. So a fine-grained texture forms when the magma cools at the surface. Coarse-grained textures form when the magma cools at depth. And this forms at the surface when you have all the froth of the lava quickly solidifying. Now what I have left are these two rocks here, sample number 53 and 57. This composition is called an intermediate composition. So when magma of intermediate composition solidifies at depth, it produces this rock, number 57, with coarse sized crystals. And when intermediate lava pours out on the surface and cools rapidly, it produces this fine-grained igneous rock, which has a gray color because it has a mixture of felsic and mafic minerals. So this is number 53.